Hello everybody and welcome to another shader graph tutorial. In this one we are going to look at again a glass shader, but in this time we are only using the camera texture and not the reflection probe. The reflection probe is only doing the reflection on the edges. This technique produces some nicer results when you are using something like a cube. But it cannot get any value outside of the viewport. So if the refraction goes outside of what you see, it's just gonna show the other part of the screen. So keep that in mind, and let's just jump into it. Alright, so we have this scene which is from this sci-fi styled modular pack from the asset store. It's for free, and I just added some post-processing. I also have my setting set to this high quality in the lightweight render pipeline, and you need to check this opaque texture so you can get the camera texture in your shader. So I already created a shader which is just like that. The first thing that you need to do is to set the surface to transparent, and just like that. And then let's start by adding our scene color node, which is going to get whatever the camera is seeing. And we are going to connect this to the emission. And just like that, if you save that, you will see your object is kind of transparent. It's not actually transparent, it's getting whatever the camera is seeing and setting it to the emission of this object. And so we want to do some refraction to that. So you can also add screen position, and that's actually what is being used here, so nothing changed like this. Now we want to add something to this on the X and Y based on the refraction, based on the normal of the object. So let's create a normal vector node and a view direction node. So the view direction is these vectors going from the camera to each vertex, and we want each one of them to be refracted based on the normal. So let's create a custom node and let's add in 3 inputs. 2 of them are going to be vector 3. Let's call this one view and this one normal, and this one IOR, which is index of refraction. And we want one output to be vector 3. Let's call it out, and let's use a string, call the function whatever you want to call it, and then just say out is equals to refract, and we want to refract the view by the normal map and with the index of refraction. Just like that, you will see your node running. Now just connect the normal to the normal, the view to the view. I forgot to connect the view direction to a normalized node first and then connect it to the refraction. The same is for the normal map. You have to connect it to a normalized node and then connect it to the refraction node, the custom function. Back to the tutorial. And get your parameter connected to the IOR, and then this is still in world coordinates, so we want to transform it from world to tangent, and it's not a position, it's a direction because it's a vector, right? And changing it from world to tangent makes it relative to where the camera is looking at. So it's basically only X and Y from what the camera is looking at, so that we can actually add it to this unwrap. So let's just add this to that and look at the result. And you can see now it's doing some refraction. You can increase this or decrease it. Right? Now you can see when it gets smaller, the edges are just stretched. So all what we want to do is to repeat this by, we want to repeat the texture that we are unwrapping. And we can do that by getting the floor of this. So if it is, let's say 2.5, it's gonna get 2, and we are going to subtract whatever the value of this, which is, for example, 2.5 from 2, which we are going to be left with 0.5. So the value output of this is always somewhere between 0 and 0.9999. So let's save that, and you can see that now we have all the basically repeating the texture, right? Now, obviously, the limitation of this technique is you cannot get a refraction to something that is outside of the viewport, right? If you want to do that, you have to use a reflection probe. Now, just to add a nice reflection on the edge so that it looks like more of a glass, let's get the reflection probe, and let's just connect it to a LURP node, to the B, and this color is going to be connected to the A, and let's connect that instead. And we are going to LURP between them using a Fresnel node. And you can obviously have a parameter for the power of the Fresnel. Oops, let's save that, close, open, and let's use that. And so 0 is full reflective, and you can see I have a reflection probe in here. And no, not this one. Increasing the power, you can see now it's the reflection is only on the edges. Yeah. So that's gonna be it for this tutorial. Thank you so much for watching, and don't forget to subscribe, and have a nice one.